Welcome everyone to the live stream, and happy Father's Day to all of you who are here and not here, who are watching now and later. So let's pray and we'll get started. God, thank you so much for this morning. Thank you for our time to be together and to talk about your creation as we focus on the things that you've made and how amazing they are. Help us to gain as much from this as possible. And we love you so much and we thank you for Jesus. Help us to live for him, and we pray in Christ's name, amen. So here we are in our Foolish Science series, part 2. And I guess the goal of this is to make science less foolish. So to look at everything that we've talked about from the last, this is part 11 on the spiritual warfare series. This series will continue and go on and on and on and on and on. But one point I made last week that's very relevant is how science is compatible with Christianity and incompatible with atheism. And I want us to understand this on a very deep level. But as we get into the points today, I want us to try to absorb as much of this as possible. And if you can't absorb it, at least marvel at it. So it's a lot. So this is the book that most of today's message came from. And I only picked 2 points out of this entire book to focus on. And it's just fascinating. This is Signature in the Cell by Meyer. Very scientific book. It is not religiously biased. It's incredibly straightforward and very scientific, very academic. And I'm going to try my best to bring about some of the main points so that we can all walk away with this just in marvel of God's creation. And before I get started too, it's really ironic. Last night, Julie and I were listening to this lecture from someone in Creation Ministries at CMI, something like that. I couldn't remember now. But anyway, they did this study at a university in Atlanta where they took a film crew out and started interviewing kids randomly, college students, whatever, and to see if they still believed in God after going to college. So he said they interviewed hundreds of kids, and their questions were these. He said, first, were you raised in a Christian household? And if they said yes, then they were able to ask them more questions, because he said they only wanted to interview kids who were raised in a Christian family. So out of the hundreds, I didn't get an exact number, that answered yes, they were raised in a Christian household. The second question was, do you believe in creation or evolution? And out of all of them, only 5 said they still believed in creation. Every other kid said that they now believed in evolution. Then the follow-up question was, do you still go to church? Or do you still...
First they asked them, were you taught the scientific reasons that support creation?
Oh, that was question 3.
And only 5 kids said yes, they were taught that.
So the kids who were taught
and all 5 of them still believed
yes.
in creation.
Okay, so then there was that other question, which was, were you taught the reasons that science support creation?
Yeah.
And those kids who still believe in creation were taught that creation is conducive with the Bible or works with the Bible. And then those 5 were the only 5 who still attended church. So it was amazing to see the correlation between what we're doing today, teaching...
Just to get the study right, there was 1 kid who believed in evolution now who still went to church.
Yes.
But there were hundreds of kids. Only 5 were taught creation. They all still believed and went to church. And then out of all the other kids who said they now believed in evolution, there was 1.
Yes. So if you didn't hear through the microphone, what Julie was adding was the part I had left out, which was there was 1 kid outside of the 5 creation believers who believed in evolution who still managed to keep his faith in God and go to church. So just saying that the studies that they did proved a significant correlation between understanding the scientific basis for creationism and believing in Genesis and believing in the biblical account, and kids maintaining their faith through college. Because once they get assaulted by secular ideology and the evolutionary theory, and they're out of the bubble of your household, if they go down that path, it will likely lead to a complete dissolution of their faith. So this is extremely important stuff, even though, ironically, this sermon has the least amount of scripture of any sermon I'll preach, like period, because it goes into so much so many things that aren't scripturally scripture. I mean, we're not dealing with scripture here. We're dealing with the creation. So let's get into it. Remember, the ultimate debate is about truth. And what we're doing here is to take our stand against the devil's schemes. We want to be strong in the Lord and in his mighty power. We want to put on the full armor of God to take our stand against the devil's schemes. So Paul says in verse 14 of Ephesians 6, "Stand firm then with the belt of truth buckled around your waist." This is the goal, to have the truth of God buckled around our waist. Last week we looked at these 5 fundamental truths. We are on the side of truth. So as we look at what we see today from science, it is affirming of what we believe in the Bible. 2, the Bible has always been right, and it still is. This is a fundamental truth, and that's why we're on the side of truth. Satan, truth 3, Satan is actively suppressing the truth. He's actively fighting against the truth to try to squash it, to push it away for people not to see it. And that means that the truth is hidden behind these lies. When we hear these lies of Satan, we need to understand that he's suppressing it. He's covering up. He's trying to hide the truth with the things that the world is telling us. And then finally, if we want to know the truth, we need to think like Jesus. We need to think biblically. We need to know, what creation means, that the Bible is written by the author and creator of all things, and to move forward with that biblical worldview. We looked at a couple quotes. This was one from last week, which it'll just be great kindle for the fire that we're about to burn. We're about to burn up everything it's just great. So he says, "The universe we observe has precisely the properties we should expect if there is at bottom no design, no purpose, no evil, no good, nothing but blind, pitiless indifference." And you hear his maniacal laugh after saying it. Mwahahaha. And he's like the evil villain in his lair, and the camera pans out, and there's like just darkness and gloom surrounding him. That's what I picture when I picture this quote, like the evil maniacal bad guy in the movie. The reality is, that everything in the universe, the human body, nature, they're all intricately fine-tuned to an exponential degree. And we're going to look at that today. The other quote from last week I thought was excellent was, "The feature of living matter that most demands explanation," which I'll give you today, Richard Dawkins, "is that it is almost unimaginably complicated." Living matter is unimaginably complicated in directions that convey a powerful illusion of deliberate design. So if that isn't Satan himself, then I don't know what is. Satan cannot be more clever in lacing his lie with all of these words that talk about God. The complicated nature, the design nature. It's unimaginably complicated. If that doesn't scream God's existence, I don't know what is. And yet people read that and then they're left just blindly ignorant and completely just deceived into thinking that this happened by chance. So, as I said before, science is fully compatible with our belief in God and completely contradictory to atheism. And we have to make definitive statements like this in the same way that when I teach on God's wrath. This is very similar to my views on that. And once you have accepted and integrated a balanced view of God's nature, and you hear me talk about God's wrath, you're almost like, okay, Paul, seriously, we've got the God's wrath thing. You can back off a little bit. But I still feel the need sometimes to push the issue in order to balance the complete unfair leaning that has occurred with God's love. To balance it, we have to really push the other way so that we can see both sides. So in this sense, I'm not trying to balance it. I'm trying to completely counteract a force that has pushed us in such a wrong direction that our brains have almost been programmed to think that science and faith are incompatible. I mean, I say science and faith are compatible, and we're like, no, they're not. Science and faith and religion have nothing to do with each other, and God and science, they don't work together, and you can't do this and that. Wrong! Wrong! Science and God are fully compatible, and atheism and science are completely contradictory, and we're going to show that with scientific proof of God's existence and answers to the evolutionary theory. It's just fascinating when Christians are so ignorant as to think that there isn't proof for God's existence. And they walk around like, I just believe by faith, blind faith. You know, you can't prove God's existence. Wrong. You can. We can 150 billion% prove God's existence without a shadow of a doubt. And if you want even more detailed proof, there are 3 really long books that I've read that aren't even religiously like slanted. There's no like religion, or he never even mentions the Bible in these books. And you walk away from them with this absolute, concrete, definitive answer that God exists. Definitively. Like, it's so definitive that people who, this quote from Dawkins from last week that said, if you don't believe in evolution, you're an idiot, is the exact opposite of reality. If you believe in evolution, you are a raving moron and an absolute lunatic, because you look at some of this stuff and you walk away with it and you're like, you would literally have to be crazy. You'd have to be crazy to believe in evolution. So here we go. Is there evidence for God's existence? Well, if he exists, there is. That's logic, that's reason. The same reasoning that would say, if you believe that Paul exists, I'm not talking about me, not the biblical writer Paul, but me. If you believe I exist, there's evidence for my existence. Okay? You can prove that I exist. And people say, but you can't see God. Well, you could say the same thing about a lot of people that have lived in the past. In fact, one of these books talks about Napoleon and the fact he was just a random example that he picked. But the fact that we can go back and see all these proofs of Napoleon's existence, but none of us have ever seen him. And so the same theory applies. Like, just because you can't actually reach out and touch God, which I might argue that we can in many ways, and people use that as, oh, you can't see him. Like, okay, people just say dumb things when they don't like the answers. So let's look at it. How to build a case for God's existence. Now, this is the premise for today and next week. We'll see how far we get, and we'll go from there. But now, when you're talking with people, now I'm trying to phrase this in such a way, I'm trying to package this in such a way for kids and adults that we can walk away from this with the most basic understanding of an extremely complicated idea that you can present to others in a definitive way that makes you look intelligent, like you understand what you're talking about, and completely destroys the opposition, like blows them into complete and utter oblivion, like setting off a nuke in their worldview. That's what we want to do, because that's what they've been doing to us for 150 years. They've been setting off nukes in Christian worldview and trying to make us look like we're idiots when we have all the evidence on our side, but they've shifted it so much and lied to us for so long that even Christians don't understand. Even Christians try to blend evolution and creationism, and there's this theistic evolution idea, which is total trash. Anyway, now let's keep going. First, when you're getting into discussions on the proof of God's existence, you need to focus the discussion on one field. And what I mean by that is there are 3 fields to choose from. You've got the cell, you've got life, and then you've got the universe. And I've broken them down, and really I'm copying Stephen Meyer's 3 books. So Signature in the Cell, you could deal with microbiology, which is really, really small stuff. DNA, cells, proteins, things that we'll talk about today. Then you could deal with bigger things. Okay, notice we go from small to medium. Humans and animals, okay? Biology, which I couldn't put biology here because cells are biology. These are both biology. So we have little microbiology, then we have life, humans and animals. Then you go really big, talk about the universe. So if you're going to get into a discussion about God or God's existence with someone, you need to start somewhere. You can't just be like, fair game, let's talk about it all. No, you'll literally, it'll just be overwhelming. I'm gonna give you things to say about each of these. Today is the cell, DNA and information. So let's begin with that. And you might say, but I'm not a biologist. Sorry, that was a total joke about the Supreme Court justice and what is a woman? And she's like, I don't know, I'm not a biologist. Okay, so that was a side point. Now, let's remember these main points. These are going to be your talking points for the cell, for DNA, and for proof of God's existence from a microbiology standpoint. Number one, your main point is information, okay? Main point 2 will be complexity, and the main point number 3, or the third main point, if I speak grammatically correct and form sentences well, would be experience. Notice how I very conveniently created an acronym for easy memory, ICE. We're going to dump some ice on their argument here. You've got information, complexity, and experience. How does this work? What you'll do is you'll make an argument for information based on experience, then you'll make an argument for complexity based on experience. So there's only 2 points here, and your basis for these 2 points come from experience. Now let me just set a little bit of foundation. How does my experience help prove the argument of God's existence for information and complexity? This is what you need to have deeply rooted in your mind. The way the universe is working now helps us understand the way it worked back then. So we understand, as one of the scientists in all of Stephen Meyer's books, I don't remember which one he quoted, but we understand the past by understanding the present, or the way we understand the present helps us understand the past. So we look around at the way the world works now, and we say, we have a pretty good idea on how the way the world works now. That should help us understand the way the world worked then. Once you start to break reality, which is what evolution does, they'll start to say things like this. The way the world worked then is nothing like the way the world works now. Let me prove it to you. And they'll go blah, 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 blah. And you'll go, oh, that makes a lot of sense. Except when you look around, you say, I don't see that. The way I see the world working is that every day I wake up, the sun rises. And it has been for as long as I can remember. And if I asked my great-grandparents, they'd probably say the sun rises on the same horizon and sets on the same, and the earth rotates around the sun the same way, and oxygen and carbon dioxide and the way I breathe and the way the body works and the way babies are made and male and female gender, it all seems to work the same as it always has. In fact, we've never documented in science ever any major shift in any way the world has functioned. That's why we have laws of physics. That's why we have the laws of nature. That's why we can study science, period. Because science proves things that are repeatable. Yet, when it comes to this mystical world of evolution, nothing is repeatable. In fact, nothing works the same way that it does now back then. And they try to create this weird dichotomy that states that the world as it started existed for millions and millions and millions of years, and then all of a sudden it drastically shifted and it works nothing like that anymore. And they're going to try to sell you this just total load of baloney. And everyone's going to be like, oh, that makes a lot of sense. It doesn't work anything like it. That's why we can't observe any of it, because it all changed. And that's nonsense. So experience, and science is built on experience. And when you define science by observation and understanding, then these 2 points are locked down, solid, concrete proof of what we're about to look at. Now, let's start with information. There is specified information in the cell. It's called DNA. Now, when we talk about specified information, what you need to understand is specified information is different from what scientists call Shannon information. Now, I'm not putting a lot of this up on the screen because I don't want to go into super detail on it, but I'll give you an example. ABC, 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 ABC. That's information, okay? It's not useful information. In fact, that information can be reduced to an algorithm or a set of computer code that's just 2 lines long that says print ABC and repeat. And that set of code can repeat ABC infinitely. And you'll have some information. What do you do with that? Nothing. You can't do much. It's just 3 letters that repeat. Specified information is information that achieves a purpose. It's specified, meaning it's specific and it's for a purpose. Bill Gates from last week told us that DNA is like a computer program, but far, far more advanced than any software ever created. This gives us the idea of what specified information is. If I had a line of computer code that said ABC over and over 1 billion times, that computer code would do nothing. It could not achieve any purpose or function whatsoever. Yet it does communicate information. What the point here is, evolutionists tried to prove for a long time that DNA is full of Shannon information, meaning that the arrangement of the code in DNA had no particular purpose. It was just there. It was just a bunch of letters until we proved that every single segment, until we mapped the genome, okay, that's what it was called, mapping the human genome, until we proved that every 3-letter character was associated with an amino acid. And those amino acids were assembled to make proteins. That's what DNA does. It is the code for building proteins. And guess what proteins do? Proteins build cells. Okay? What do cells do? Cells build tissue and bones. Okay? The whole body is made up of tissue and bones. All the organs are made up of tissues. Muscles are tissues. Then you've got organs, bones, and tissues make a body. So, from DNA, you have the instruction manual for assembling the parts that make the body. Now, this is very important. DNA itself does not tell the body, or it doesn't tell the system what kind of body to make. This is really interesting. And I'll talk about that more in just a second. But there are actually 2 codes in the body. There's DNA and there's something called a sugar code, which only comes from embryos. And without the embryo, the DNA doesn't know which body plan to make. And you can't make a body plan without an embryo. And so DNA by itself could not have evolved into a human or anything else without a sugar code to tell it what kind of body plan to make. But let's keep going. Let's look at how complex the activity of copying DNA actually is. Now, why is this important? Well, because DNA, one strand doesn't do anything by itself. You need billions of strands of DNA in your body in order to make all these proteins and organs and tissues. I mean, that DNA has to be replicated in your body, and that's how the instructions get to all the different parts of your body to make all of the parts, like the cells and the proteins and the organs and bones and tissues and everything else. So we will see what copying DNA actually looks like. This is great. Okay, they were able to take computer generated, they were able to animate it. Okay, this is not actual footage because we don't have, well, light doesn't reflect down to a level that we could actually take a picture of DNA. We have to use magnetic scanning and things that I don't understand how they were able to take these images, but this is highly accurate scientifically. So check this out. Okay. DNA replication, there's little notes that come up on the screen. Billions of these molecular machines are copying your DNA. Okay, you've got a DNA strand coming in. These little globs are proteins. Okay, there's a close-up. And you've just got this strand of DNA coming into a protein as it's just chomping on it, separating it, copying it, building proteins. There are proteins coming off of that. That's real-time speed here. It's quite amazing when you look at how fast this DNA strand comes in. comes out. RNA is being made too at the same time, which then goes and helps make the proteins through mRNA and other things. So this is the start of a gene for bone strength protein, okay? So that's vitamin D up there. It's going to come along and attach to this little protein, and then it changes colors, which is really cool. I doubt that's really how it looks in the body, though. I don't think we have color-changing proteins in the body, but gene transcription. So that just made a little strand of RNA copying off the DNA to go and make, so that's the RNA coming off up there. And then the DNA just goes through. We're going to talk about that in just a second, that blue thing, which is the transcription device. Now this is really cool. So this is showing it inside. Those are the letters of the DNA going through. Now watch this speed up, because this is showing you very slowly so that you can actually understand what's going on. That's real time. That's how fast the DNA goes through that protein, and it's actually copying letters into a strand of RNA which goes off and binds to the amino acids to make the proteins. I mean, he just said that, the guy who did the TED Talk and showed that video said that was like 10 years of biology that they had to study in order to create that one video. But it's fascinating to see these machines, literal machines. Now they look like blobs, but these are like actual machines processing information. You saw the letters because each DNA sequence has 2 letters and the double helix, and they're bound together, and they separate and copy. Anyway, next, let's look at how DNA is transcribed and makes a protein. So we're going to look at the process when that DNA, when it zoomed in and it slowed down, it showed the letters and the DNA is coming through, the RNA is coming off the top. It's going to get a little bit more involved here. I'm going to turn the volume up here.
Here is a cell, the basic unit of all living tissue. In most human cells, there is a structure called the nucleus. The nucleus contains the genome. In humans, the genome is split between 23 pairs of chromosomes. Each chromosome contains a long strand of DNA, tightly packaged around proteins called histones. Within the DNA are sections called genes. These genes contain the instructions for making proteins. When a gene is switched on, an enzyme called RNA polymerase attaches to the start of the gene. It moves along the DNA, making a strand of messenger RNA out of free bases in the nucleus. The DNA code determines the order in which the free bases are added to the messenger RNA. This process is called transcription.
This is so great.
Before the messenger RNA can be used as a template for the production of proteins, it needs to be processed. This involves removing and adding sections of RNA.
Like, that sounds
The messenger
complicated.
RNA then moves out of the nucleus into the cytoplasm.
Look at that little strand of little train.
Protein factories in the cytoplasm, called ribosomes, bind to the messenger RNA. The ribosome reads the code in the messenger RNA to
This is
produce
so-
a chain made up of amino acids. There are 20 different types of amino acid. Transfer RNA molecules carry the amino acids to the ribosome.
Such a cute little picture. It's like,
The messenger RNA is read 3 bases at a time. As each triplet is read, a transfer RNA delivers the corresponding amino acid.
I know. Here we have an amino
This is
acid.
added to a growing chain of
Chain.
amino acids.
There we go. This is important. I'll talk about this in a second.
Once the last amino acid has been added, the chain folds into a complex 3D shape to form the protein.
Boom! And there you have it. Protein. Folds. It's so great. So she's in there talking about this stuff as if this is like normal, like for things to do this. when this is such an incredibly complex process. And those amino acids, there's 20 of them that are read off of that messenger RNA, which was copied from the DNA by other systems, that then spit off this string. And they're like, and then it folds. And you're like, it folds? What do you mean it folds? It literally compacts it. It's one strand. It'd be like a Lego building. Like take like the Death Star, okay? The Lego Death Star. It's got like 6,000 pieces. It'd be like if every one of those pieces came out of the box attached to each other. And instead of building it like piece by piece, you had to fold 6,000 Lego pieces into the Death Star. Okay? I mean, that's how the protein is made, okay? And they have to attach a certain way. It's not like they just get bunched up into a paper wad. It's not like you take a piece of paper, wad it up, protein. No, it's got a very specific place how they fold together, and we're going to talk about that. So look at this chart real quick, okay? This is a chart showing what's needed in that protein replication process and making proteins. So ATP is adenotriphosphate. That is the energy source to make all this happen. Without ATP, nothing can happen. It's the battery power to make all of this stuff move. We didn't even talk about that. Look at how ATP has an arrow to every process. So the ATP has to be used in transcription, translation, glycolysis, and DNA replication. So the DNA text down here goes into transcription, it goes into replication, because it has to be replicated to make new cells, has to be transcribed to make proteins, has to be translated, and then glycolysis is also how we get ATP. That's the process of breaking down sugar into energy and the carbs and stuff. So what I want you to see here, this is what we're doing with this big red box. We have 106 proteins involved in translation. 106, 12 involved in transcription, 12. Then we have the small molecule, which has many proteins. That's the question mark. That's like a lot. DNA replication takes 32, glycolysis takes 10, and that ends up with approximately, meaning more than, 160 proteins. This is 160 proteins just involved in that one little video sequence that I showed you, where the protein comes through, gets duplicated, translated, and I said protein. The DNA comes through, duplicated, translated, and makes protein. That's 160. So what we need to gather from this, that's just one. That's just in one DNA strand being processed. Just one. Okay? 160 proteins needed. Why is that important? Because I'm going to show you in just a second that in the estimated age of the old universe, now we are young Earth, I am a young Earth creationist, and I'll prove to you why we have to be that way eventually. Probably not this week, but in the old universe, okay, 3.5 billion years old, the amount of time since the Big Bang and that life was actually possible to start the process of evolution, 3.5 billion years, there is not enough time for one protein to evolve by random chance. How many fingers am I holding up, everyone? One. There's not enough time for one protein to evolve, one small protein. And look at how many are needed for DNA to replicate. Now, this is an extreme chicken and egg problem. Which came first, the chicken or the egg? Well, if you're an evolutionist, you have to believe the egg came first because it evolved into this little thing that then grew up into a mama chicken. But with this graph showing how DNA is transcribed and copied and translated and all this, it cannot happen step by step. All of these machines, this entire spectrum of proteins has to be present for anything to come off the DNA. DNA cannot replicate itself. DNA cannot copy itself. If you get prebiotic soup and DNA somehow manages to form itself, what does it do? Just sits there, does nothing. Has to have a series of 160 machines present in order for it to generate anything. So we're talking about information and complexity. How complex is the information in one protein? Small proteins are 150 amino acids in length. So when we saw the video and the little bubbles were forming that chain, those are amino acids, those little bubbles in the video. 150 will form a small protein. Now most proteins are in the 250 to 350 amino acid range. Those are most proteins. So if we even let's just say for the benefit of evolutionary idiocy, that we're going to form one small 150 chain amino acid protein, then that would be a small one. That's what we're going to deal with. Now remember, there are 20 amino acids that we can choose from. So if you're going to think about this evolutionarily, I just made up a word, from a materialistic standpoint, here's how you should picture this in your mind. Stephen Meyer uses the example of a bike lock. Okay, a thief is trying to steal your bike. You locked up your bike with a bike lock that has rotating combination on it, and there are 150 dials on your bike lock. And every dial has 20 letters on it. How long would it take the bike thief to randomly select the correct combination on your bike? Imagine riding your bike and getting off your bike and locking it up, and you pull your bike lock out of your pocket, except it's like the length of your leg. And it's like, this is my bike lock. It is the most secure bike lock ever. Yeah.
Big, it wouldn't do much.
I know. I mean, it'd be the size of your bike. I mean, it would literally be as long as your bike is, and it would have the chain that would go around it, and then it's like 150 sequences of dials with 20 letters on every single dial. And that's what we need. That's what evolution needs for one protein to form randomly. Evolution needs a bike thief who can randomly guess the combination to a 150 character bike lock by chance. And that, my friends, is why evolution, number one, is an absolute farce, completely stupid, and the most insane, ridiculous idea to ever come about. But that's just one protein, people. One. You need 160 to copy one DNA strand. And how many DNA strands are in your body? Billions. How many cells are in your body? Trillions. And every cell has 23 chromosomes that are packed with DNA. So, how hard would it be for one protein to evolve randomly over time? So let me give you this prison scenario. Would you rather go to prison for, you can choose, okay? I would choose not to go to prison. Be a creationist and you won't have to go to prison, okay? A, 10 years. Or B, until you flip a coin heads 100 times in a row. Okay? Those are your choices. You can either, you've been convicted of a crime and the judge says, hey, I'm going to make you a deal you can't refuse. I'll either give you 10 years in prison or here's a coin. Flip it heads 100 times in a row on a surveillance camera, so I know you don't lie or cheat. And as soon as you flip the coin 100 times heads in a row, you can go. Score. You start looking around. You look at your lawyer, and your lawyer's like, no, go with A. Go with A. You're like, what? I'm the luckiest man in the world. I can flip a coin 100 times heads in a row, no problem. He starts putting in his calculator. Let's see how this would work. 10 years of coin flips. Meaning, if you flipped, and Stephen Meyer came up with this number, 10 to the 7th power, if you flip for 6 days a week, for 8 hours a day, nonstop. Take one day off, you would flip 10 to the 7th power flips. Your odds of flipping 100 heads in a row are 10 to the 30th power. Meaning you only get 10 to the 7th power chances to get that one out of 10 to the 30th. Now, when you understand exponents, you can't put a 10 to the 7, you can't put 7 over 10 to get the relationship. It's not 1 and 4, because 10 and 7 times 4 is 28. So it's like, oh, that's like a fourth of those. No, that's not even close. It's the tiniest fraction of 10 to the 30th. So what we're saying is it might happen in 1 trillion years. Your odds of 1 in 10 to the 30th based on this many coin flips every 10 years means that you might hit that 1 if you flipped coins for 1 trillion years. So those are your choices. The judge was saying you can go to jail for 10 years or 1 trillion years. 1 trillion is 1 with 12 zeros. Trillion. And you're like, that's a no-brainer. What would you pick? I mean, that's such an astronomical difference. Why would you even risk it? Who would risk it? Anybody? Would anyone risk flipping a coin for 10 years, 1 trillion? It'd be infinite life sentences. You would never get out. That number is so high, no one would even try. No one with those odds would even try to attempt it. So let's go back to the protein. Functional folds of a given length, meaning that when you get the right number of amino acids together, how many of those will fold into a proper protein? Well, let's say we're looking for 1. We're looking for 1 protein that will fold together. Now, how many ways can we assemble those amino acids in that length? Okay, so we're looking at 150 amino acids. How many ways can we assemble 20 amino acids? Meaning, how many possible bike combinations did our bike thief have to try? That number. Y'all grasping this number? When we were flipping 100 coins heads, meaning it's a binary choice, male or female, I'm sorry, heads or tails. My mind is just stuck on gender. So you have a coin with 2 choices, 100 flips is 10 to the 30th power, and it would take you 1 trillion years to do that. So how many years would it take the bike thief to unlock a combination that has 10 to the 77th power choices? Your bike lock with 150 dials on it with 20 amino acids on every dial of the bike lock has 10 to the 77th power choices. Your bike thief has to get 1 of them to unlock your bike. Wow. 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 Okay, wow. Like seriously, 10 to the 30th is the tiniest fraction of 10 to the 77th. I mean, if it would take you 1 trillion years to flip heads 100 times, how many years would it take for that? Like 1 trillion, 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 trillion. Okay? That's about how many years it would take. And yet evolution says that not only did 1 protein form randomly, that enough formed to build DNA and cells and life as we know it, and that only happened in a very short 3.5 billion years. See, that's the thing you've got to understand by this argument, is that science wants to tell you they just need more time. We just need more time. 3 billion, 4 billion, 5 billion years, that's fine. Give them 100 billion. Say, listen, I know your dating system stinks, but let's just give you 100 billion years for evolution. Okay, great, thanks. Then evolution definitely happened. And you'll say, really? Evolution couldn't happen in 1 trillion, 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 trillion years. Say it so many times it sounds weird. Okay, so how do we prove that? Well, Dr. Axe, which I've referred to him a couple times, he calculated the number of trials that we've had in the course of long life, okay, old Earth life, 3.5 billion years. He calculated the number of tries that if every single option, meaning that if the bike thief had his 150 combination lock, and he started at the beginning of time with long Earth time, 3.5 billion years, how many chances would he have had to get the right combination from the beginning of time to now? Non-stop, no breaking for eating, no potty breaks, no sleeping. As fast as an organism could possibly assemble, how many chances would that thief have had to steal your bike in the course of all of long history, 10 to the 40th power? That's how many chances he would have total, 10 to the 40th power.
Try to steal them.
Yeah, he wouldn't have even, I mean, that's nonstop for 3.5 billion years. That's how many chances the organisms had to assemble into one protein fold that could fold into a proper protein, one amino acid chain that could fold into a proper protein. That's how many chances we've had in the course of history. And remember, for one protein, you have to find that amino acid segment out of 10 to the 77th power, which is, again, a less than a fraction of one. Like, it's the tiniest fraction. You can't even get there, not even for one. It is literally impossible for one protein to form in the 3.5 billion years of the universe's existence. Now, again, the 3.5 billion years, that's the old Earth idea. We know that the universe is only 6,000 years old, and the Earth and humans have only been here for 6,000 years. And we can get into all the kinds of dating issues that science has, but again, they're all lies. So, the atheist, again, will say it just takes a long time. And your answer is, there isn't enough time in existence. That's your answer. When they try to argue evolution, they don't know what they're talking about. They've never looked at the numbers. They've never looked at the data. The amount of information that we need in one protein of 150 length amino acids, just 150. That's one small protein, but we need 160 proteins that are at least 200 amino acids or longer. So it's not enough time. So, but could DNA form by random chance over time? No. It's not. Could DNA form by random chance? No. So the question that they're asking is, if we could get DNA to form by random chance over time, it could solve everything. And if we could just explain DNA, that everything could come from that, and it would just solve the problem of life as we know it. Evolution and science are pushing towards these ideas. And if you ever get around to reading these books, or if you just go out and listen to science and these evolutionary biologists talk, it's really interesting, because what they'll do is they'll disprove themselves very regularly. Every few years, this new theory of evolution comes out where they say, well, we admit the odds of that happening, pretty impossible. So what do we need? Oh, we need self-organizing proteins. We need proteins that can put themselves together, because randomly that can't happen. Randomly, we know that'll never happen. It's too random, too impossible. So they'll just self-assemble. There actually was a theory that the DNA, the letters were magnetically attracted to each other, but that disproves itself, because then every pair would be exactly, they would be able to attach to any, and we know that every two in DNA have to have a mutual pair. They aren't all interchangeable. Anyway, the point here is that even if we could get DNA, I put this asterisk right here to say the sugar code is absolutely amazing, and that's what gives the DNA the body plan to work with. And here's how you would explain that. Imagine you're going to build a skyscraper, and semi-trucks come and drop off all the raw materials to build the skyscraper. They drop off the concrete or the bricks, the concrete blocks, the rebar, all the electrical wire, the I-beams, all the steel, and all of the windows and the glass and the carpet and the drywall, all of these things. Those are the organs and the tissues and the bones of the body. That's what DNA tells us how to make. DNA is in the factory making the rebar and the drywall and the steel and the electrical wire. And then the DNA is like, here you go, as it dumps it out onto the ground at the build site. Well, what puts all of those things together? Because all DNA does is it processes these proteins and spits them out. But what puts them together? What makes the human body out of all of these proteins? The sugar code. Where does the sugar code come from? The embryo. The embryo holds the body plan for the organism, whether it's an animal or a human or anything with DNA. The DNA has the code for all of the parts, and then the sugar code comes along and tells it the body plan. So the sugar code is the blueprint. The sugar code is the blueprint for the building. Tells it the size and the shape and the form of the body, 2 arms, 2 legs, 2 eyes, whatever. And it's really amazing. You can look it up. There's some great articles on the sugar code and how it works. and how the sugar code is the blueprint and the DNA is literally the raw material chain, which is why, it's so cool, which is why when you get into analyzing the DNA of like an ape and the DNA of a human, why they're 80% similar in evolution. It's like, oh, this is proof that we evolved from apes. And you're like, you have no clue what you're talking about, because just because the DNA builds similar parts for animals and humans means nothing. What's even more interesting in DNA across all humanity, the only difference between all of humanity's DNA is less than 1%. You look at how different all people are with their hair and their body types and their eyes and everything. All of the differences of every human being on earth is made up of less than 1% of our DNA. Okay, that's fascinating. And that's how complicated DNA is. And so when you start looking at it in depth, it's just crazy. So let's use an experience. Let's use experience to make an educated guess about the origin of specified information. So like I said, you make that argument by telling them how complicated the information is in DNA, amino acids, proteins, however much of that you want to say. And then you say, well, let's ask ourselves, where did this information come from to make it? Is it random? Did it just randomly come about? Did it self-assemble? What did it do? Or is it specified? So I'm going to show you a string of letters, and you're going to tell me if it's random or if it's specified information, okay? So look at that sequence and tell me what kind of information is this? Is it random? Is this random? Anybody? Is that random? Does that look random? Okay, are you sure? You're sure there's no hidden message in there?
Yeah, that's random.
Okay, this is not difficult. This is really easy. I just hit the keyboard with my hand 3 times, like boom, boom, boom. In fact, it was funny because I kept hitting it and would get the same repeated sequence because I'd hit it the same way. I had to really try hard to like hit the keys differently. Okay, good. Now, what about this next sequence? What is that? Is that information? You read it and you understand it and you're like, whoa, there are words on the screen. It's amazing. Okay, let's try again. How about this one? Kajudigurapabudibulidid. It's random. Okay, guys, I just hit the keyboard. Random. Okay. Pretty easy, right? Let's try one more. What does that say? Can you read it?
Yeah.
Good. Dad likes football. Okay, so here's one more. Really complicated one. See if this is random or specified. Anybody? Do y'all see any code hidden in there? Any code hidden in that mess of letters? Okay. This is so great. Here's the argument of intelligent design. This is how we know for a fact that God exists. In the known universe, random chances never produced specified information. Never. That is a word you can take to the bank. You can take that down the street and cash that. Like that is money. Never. Random chance has never produced specified information.
Kind of like that time you took the bananagram thing and told us to.
The bananagrams, yeah. I told you to grab letters out of the bananagrams. I think the best, and you could say, well, I picked up I and then randomly picked T and I got it. That's specified information. And what are you going to do with it? We're looking for a sentence here. We're looking for a sentence of at least 150 characters. Okay? We're looking for a reasonable amount. Okay? And you say never. See, Paul, it's not never because I got a 2-letter word. And you're like, okay, you can take your 2-letter word and you can go make some DNA out of it, okay? This is the truth. When we're dealing with the same concept here, we're not dealing with 2-letter words. We're not dealing with, I got the word do, D-O, or D-O-T, I got 3 letters, it's amazing, see, specified. If we're going to argue out of stupidity, then let's just be stupid together, okay? That's stupid. That's not what we're talking about. We're not talking about 3-letter words. We're talking about sentences, okay? And never, it just has never happened. So, only intelligence can make specified information of any reasonable length. So we have these arguments, and then we've got the atheist who will say, wrong, it's been proven by computer simulation. And that's not true. Richard Dawkins created a computer program that generated a sentence from a Shakespeare play randomly. Yeah, they'll even tell you that. They'll say, guess what? Richard Dawkins did it. He created a computer that simulated natural selection and evolution, and it generated a sentence. And you'll go, well, there you have it. I'm disproven.
He said, no, I bet he told it. He just told it to do that.
He told it what to look for. Okay, the computer was programmed with the target that guided its selection of random letters. This is how it happened. So they programmed the computer to say, when you see a series of letters, pick the one that most closely resembles the target. So the computer would scan random letters, and this is how they think natural selection works, which is, again, another reason why it doesn't happen. Because natural selection in the sense of evolution has a target that it works for, as if it's omnipresent or omniscient or knows what it's looking for, when that completely contradicts the point of random. Anyway, the computer would see letter, 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 letter. Okay, there are 3 letters that match the target. We'll keep this strand. Now give me 3 more random strands. Oh, that one has more letters that match the target, so we'll keep these letters and replace all the other letters with more random letters. And now I've got 5 out of 12 letters that match, so we'll keep that, switch all the other letters until we get more letters that match the target. And the computer program was able to compare the random sequences to the target until it generated the sentence that it needed, which is a complete sham, a total lie. And it's just, again, nonsense that science is like trying to force on you to prove things that can't be proven. So, complexity. Let's move on to the second point, irreducible complexity. It's the minimum number of parts required to achieve basic functionality. This is sort of the point I've already made, so this point will go through a little bit faster. The cell needs all of its parts to function, but before, let's watch this little video. This is so great. That's a cell. Look at that little glob thing. This is just to show you how cool a cell is when they animate it. We've seen this already. That's DNA and the histones that it wraps around. That's at 10 million magnification. We've seen this view already. This is gene transcription, so the DNA being copied and transcribed into messenger RNA, which then comes around later and makes proteins. Look at this. Look at these little, like, how it gets into the nucleus. It's like going through little portals. I mean, this is literally like the exterior of the nucleus with these things. This is so cool. And then back to the beginning. That's what the nucleus looks like in the cell. I think that was it. So the cell is an amazing factory full of molecular machines. Okay, so watch this. Let me show you one more machine video.
You can see it moving. The nuclear envelope breaks down. These sausage-shaped things are the chromosomes. We'll focus on them. They go through this very striking motion that is focused on these little red spots. When the cell feels it's ready to go, it rips apart the chromosome. One set of DNA goes to one side, the other side gets the other set of DNA, identical copies of DNA, and then the cell splits down.
That's actual, this is real. This is real footage of a cell splitting.
Right now inside of you.
That was not computer
Now we're
generated.
going to rewind and just focus on the chromosomes.
Now we'll go
Look at its
into
structure and describe it.
computer generated.
So again, here we are at that equator moment. The chromosomes line up, and if we isolate just one chromosome, we're going to pull it out and have a look at its structure. So this is one of the biggest molecular structures that you have, in, at least as far as we've discovered so far, inside of us. So this is a single chromosome, and you have 2 strands of DNA in each chromosome. One is bundled up into one sausage, the other strand is bundled up into the other sausage.
So it's
These
one
things that are
DNA,
whiskers that
it's
are
one.
sticking out from either side are the dynamic scaffolding of the cell. They're called microtubules, but name's not so important. But what we're going to focus on is this red region. I've labeled it red here. And it's the interface between the dynamic scaffolding and the chromosomes. It is obviously central to the movement of the chromosomes. We have no idea, really, as to how it's achieving that movement.
We don't
We've been
know.
studying this thing called the kinetochore for over 100 years.
100 years. They
And we're
still don't
just
know.
beginning to discover what it's all about.
This is so cool. Watch
It is
this.
made up of about 200 different types of proteins, thousands of proteins in total. It is a signal broadcasting system. It broadcasts through chemical signals, telling the rest of the cell when it's ready, when it feels that everything is aligned and ready to go for the separation of the chromosomes.
Watch this.
It is able to couple onto the growing and shrinking microtubules. It's transiently, it's involved with the growing of the microtubules, and it's able to transiently couple onto them. It's also a tension sensing system. It's able to feel when the cell is ready, when the chromosome is correctly positioned. It's turning green here because it feels that everything is just right. And you'll see that there's one little
just
thing
right.
that's still remaining red. And it's walked away.
Look at these
down
little
the
things.
microtubules. That is the signal broadcasting system sending out the stop signal, and it's walked away. I mean, it's that mechanical.
Look at these things.
It's molecular clockwork. This is how you work at the molecular scale. So, with a little bit of molecular eye candy,
Look at that.
we've got kinesins, which are the orange ones. They're little molecular courier molecules walking one way. And here's
You got little bugs in your body.
and they've got their long legs so they can step around obstacles and so on. So again, this is all derived accurately from the science.
That is a picture of what's going on in the information network between the chromosomes in your cell. And he said it was 200 proteins for each of those little things, and then all the millions or whatever proteins that make this information network that talk about all of it. And all these parts are made up of proteins. So what have we learned about proteins? Okay, we learned that this system here is interconnected, and you need all of these parts in order to transcribe the protein. Remember, 160 different proteins just for this. And like I said before, this is just one machine doing one copy on one part of one DNA strand. That's just one. In total, there are between 90 to 140 million proteins in a single cell. That's in one cell, 90 to 140 million. There's a range there. And yes, there are cells in other organisms that have less proteins than that. This is referring to a human cell. And remember how hard it is to make one protein. So now we're dealing with complexity here. So could this level of complexity have arisen by chance or a series of random mutations? Now, the mutation part is interesting because it's not just, they don't just adhere to this idea of random chances and stuff. They actually believe, some scientists believe, that they had starting points where there were groups already together, and you're like, how are they already together? Where did they come from? Where did this prebiotic soup come from? Where did this come from? And they won't answer any of those questions. They'll just say, it just had a bunch of tries, and the proteins were there, and they just mutated over time. It was already assembled, and they just changed until they made what we wanted. Well, let's look at our experience again. So what does our experience tell us about random mutations over time when things mutate? So we start with that, like the computer program, how it sort of generated the sentence over randomly mutating the letters and stuff. So we've already established that the random chance, it never produces information. But what if we have a series and can just change the letters one at a time? Well, let's look at this series. Dad likes football. We're going to change one letter randomly every time. Just one change every time. That's 10 iterations of random changes. Now, did the sentence get more complex or less complex over time? Yeah, because guess what? Random changes always decrease information every time. Why? Because you had information to begin with and you changed it. I mean, come on, people. It's like if you take something that works and start messing with it, it doesn't become more functional. I mean, unless you have an intelligent engineer who's refining the process and modifying systems for a purpose that he knows he's trying to achieve. And so he breaks down, replaces, and improves things with a random, and not random, but with an intelligence and an engineer who understands functional systems. But that's not random. None of that's random. But you just take a system and you're like, let me just move some things around. Never works. So our experience, again, also informs us that mutations are never a preferred outcome in biology. This is the other truth. Every time, and I might be going too fast for you to put the blanks in, but hopefully you'll catch up because we're trying to get done here. So every time an experiment is mutated or altered a developing genome, it has died. Mutations do not produce viable embryos. There was a study done on fruit flies where they mutated the genome of the fruit fly with radiation. every single time it died. Every single time. We see mutations in the human genome occasionally when we have mostly unviable babies. Depending on the level of mutation, actually, some babies can be born without an arm or without a leg and things that aren't necessarily vital for life. But if the genome mutates enough, it dies. Mutations are never preferred, never produce better outcomes, and never in science or biology do we ever see mutations increasing the information in anything. So remember these points, okay? Information in DNA, where did it come from? In intelligence. It's the only place information can come from. Complexity. All the parts had to be there from the beginning. They could not have come about by chance because mutation, random mutation, never increases complexity. Mutations always decrease complexity. And we prove these by our experience looking out into the real world. So what do we get out of all of this that the proof of God's existence is? It is us. It's very simple. You look at a human body, you look at someone who has this increasing complexity with these little mules or the animals, they're like little insects crawling along your chromosomal information highways, and you see these things and you're like, this is the most complicated and advanced system known to man. And I come back to the ridiculous argument of aliens, and I've mentioned this before, how science has even proposed that our DNA was written by aliens. But it's fascinating that most of them come back to the idea of random chance and evolution to explain humans, because if we were, and there's this whole controversy about UFOs and aliens and NASA withholding information about UFOs and stuff, and we see these objects that are so rudimentary and sort of stupid, but we're like, we didn't make that, it must be an alien. And you look at people and you say, you know, if you were walking down the road and you came across an alien weapon like a laser or a real lightsaber or something that you knew that our technology couldn't have created, you would immediately assign it to an alien life form. You would immediately say it was from outer space or from a higher intelligence. If it was a weapon or a gun or a spaceship that was beyond our reasonable technological capabilities. Yet when you look at the human body and the cell and proteins and DNA code, admitting it's far more advanced than any computer code, what do we end up at? Random. Oh, it's random. It just randomly happened. Again, it's stupid. We just don't want to admit there's a God. We'd rather admit there are aliens than God. So, 3 premises that we have discussed. Despite a thorough search, these are actually quotes from the book. Despite a thorough search, no material causes have been discovered that demonstrate the ability to produce large amounts of specified information. None. None whatsoever. Premise 2, intelligent causes have demonstrated the ability to produce large amounts of specified information. Conclusion, intelligent design produces the most causally adequate explanation for the information present in the cell. That's what he comes down to. He says if we look at it scientifically, there's no other explanation, there's no other reason, no other cause that can answer the question, where did the information come from? None. Had to be a creator, had to be a designer. And that's why science has become foolish, because they look at what's so obvious and come up with the most outlandish, ridiculous explanations for something that could not, in a trillion years, have ever happened by chance. So, that's us. That's our interworkings and our molecular biology, if you will, just on a very basic, very tiny scale. And that hopefully wasn't too terribly unbearable. But finished really close to on time, so we'll see. We'll see how this goes from here. But anyway, thanks for participating. Let's pray. God, thank you for this time to look at the incredible workings of your creation and how you formed us in the most incredibly complex and highly advanced way that is just beyond our understanding, beyond our comprehension, beyond our ability to explain. We can just look at it and marvel at your work, at your handiwork, and the just immense level of beauty that you put into each of us in the world and creation. So we praise you and we thank you for these things, and we acknowledge you as Creator God, and we lift all this up to you in Christ's name. Amen. Brooklyn, will you hop over and stop that for me? Just click the red button at the top. So until next time, and then hit OK when that pop-up comes up.